Tutorial for question 2. A mixture of 75 mole% of propane and 25 mole% of hydrogen is burned with 25% excess air. Fractional conversions of 90% of the propane and 85% of the hydrogen are achieved. So meaning to say 90% of propane is being converted to the product and 85% of the hydrogen are converted to the product. Of the propane that reacts, 95% reacts to form CO2 and the balance reacts to form CO. Now if we see this, meaning to say there are more than one reaction in there, because propane can form CO2 and it can also form CO. The hot combustion product passes through a boiler in which heat transferred from the gas converts boiler feed water into steam. Calculate the concentration of CO in ppm on molar basis in the stack gas, meaning to say in the product gas. So if we draw it out, let's keep this one here. So we have three reactions. One is propane with O2 convert to CO2. This one is 90% of 95% of it is forming CO2. So based on this, we can see the selectivity of the reaction, so whether it selects to lean towards reaction 1 more or reaction 2 more. In reaction 2, we have propane form CO and of course H2O. So this one is a complete combustion. We know that this one is a complete combustion. And reaction 3 is the hydrogen. The hydrogen will react with oxygen in the air to form H2O, because we also have 25 mole% of hydrogen. So this one is the feed. 75 mole% of propane and 25 mole% of hydrogen is in the feed. We shall take a basis of 100 mole as the F. So over here we put 0.75, which is 75%, and the remaining is hydrogen, 25%. Air, we have air being fed in, and the composition of air is the same, which is O2 is 0.21 and N2 0.79. I know some of you may ask that, oh, air also contains other components, but it's okay. In intro, we use this one as a standard because these two compose of the mole. So unless the question stated otherwise, just use these two components, and this composition, this fraction of composition is enough. Then we will have our product. What types of product we have? Okay, let's start with here. We know that this one doesn't achieve 100% conversion of propane, because it says 90% of the propane are achieved. So you have extra 10% of propane left in here. So you have propane coming out. Next, we also have H2 coming out because 85% of the hydrogen are achieved. So we have 15% of hydrogen that is not being used in the reaction, and it comes out here. And of course we have O2. Why? Because we have excess, 25% of excess air. Then we also have N2 because it is an inert gas, so whatever amount of nitrogen goes in should come out here. Then based on our equation here, we have CO2 and we have CO. In this case, I missed out H2O. So we also have H2O. As so. So the first step is by determining the stoichiometric O2 that is required. Meaning to say we can find the amount of oxygen that is required for the propane to fully complete react, and the O2 required for hydrogen to completely react. We take the number of moles of propane that goes in, multiply by 5. So how do I get this? This one is from your reaction equation. So 1 mole of propane requires 5 mole of oxygen over here, and 1 mole of hydrogen requires only 0.5 mole of oxygen. 0.5 mole of O2 is required per mole of hydrogen. This is what it means. Substitute this in, so the number of moles of propane in is 0.75, which is the fraction, 75 mole percent, multiplied by the fit in, F, times 5, plus the number of moles of H2 that goes in, and we also know this, times 0.5. And we will get the answer of 387.5 mole. With that, we know that the theoretical O2 that is required. So, given that the air is supplied in excess 25%, right? We can find the number of moles of oxygen that goes in and multiply it by 120%. Excess is 125%. Okay, and we shall get 484.4 mole. This is the number of O2 that goes in. Then we can find the number of moles of nitrogen that goes in. Since we know its composition, the ratio here, so this is actually, let's write it like this. So number of moles of nitrogen that goes in is 79 parts, or 79 moles. This is a ratio basis, and number of moles of O2 that goes in is 21. So to find this, we just multiply this part with here, which you can find 1,822.2 moles. If you add these two up, you can find your A. Add these two up to find your A. Okay. Next, we know that 90% of conversion of propane is achieved, meaning to say there's 10% of propane that comes out. So the propane that comes out is the propane that goes in multiplied by 10%, which is 1 minus 0.9. Make sense? Substitute the values in and you get 7.5 mole. Same goes to H2. We know it is only 85% of conversion is achieved, so whatever H2 that comes out is 15% of the remaining H2 that is not used. So multiply the amount of H2 that goes in with 15%. 1 minus 0.85 is 0.15, which also equals to 15%. And you will find the number of H2 that comes out. Let's write down whatever comes out first in this part here. This one is 7.5. This one is 3.75. So the question did say that 95% reacts to form CO2, and the balance, which is 5%, reacts to form CO. So this is your reaction selectivity, which we can write it like that. CO2 to CO is 95 to the ratio of 5. Write it down in such a form, the ratio form, and we will find that the number of CO2 that comes out is actually 19 parts of number of CO that comes out. Then we can do element balance for C. So for C, what goes in that contains the element C is propane. Inside propane we have 3 moles of C. In 1 mole of propane we have 3 moles of C. Clear? Then whatever comes out that contains C, we have propane, we have CO2, and we also have CO. Substitute the values in. Okay, same goes to this, 3 moles of C in 1 mole of propane, 1 mole of C in 1 mole of carbon dioxide, and 1 mole of C in 1 mole of carbon monoxide. Substitute the values in, and also substitute equation 1 into equation 2, because we have 2 unknowns here, this and this. We have 2 unknowns here, but we also have 2 equations, so we can solve this by substituting equation 1 into equation 2. Then you can find the number of CO that comes out. With this, we can find the number of CO2 that comes out. So the number of CO2 coming out is 19 multiplied by 10.125 mole, which gives you 2.4 moles. Write this down. So what else do we still need to find? We need to find O2 out, N2 out, and H2O out. So let's do H. Whatever that goes in that contains H, we put it on the left hand side. So the compounds that contains H is propane and of course hydrogen itself. Inside the airstream we don't see any H, only here. So H over here we have 8 moles of H per mole of propane and 2 moles of H per mole of hydrogen. What comes out that has H? We have propane, hydrogen, and of course H2O. Substitute all the values in again, which we have found from previous, and we will find that the number of H2O out is this, 291.25 mole. 291.25 mole. Continue with O, because we have O and N that's not done. So for O, so the number of moles of O that goes in is oxygen, and what comes out with O is oxygen. We have carbon dioxide contains O also. Carbon monoxide also contains the element O, and H2O contains the element O. With that, we can find, and this one is our unknown, so we can find the oxygen that comes up is 141.31 mole. 141.31 mole. So the number of nitrogen that comes out is equal to the number of moles of nitrogen that goes in, which is 1822.2. Plus all the product in P stream, and I've missed out this one. Sum these up, sum this part up, sum this up, and you should get 2468 more. And the question wants you to find the concentration of carbon monoxide. So take the amount of carbon monoxide in P divided by the total amount of the total number of moles of P, which is 2468, multiplied by 10 to the power of 6. So if you want to convert to ppm, just multiply it with 10 to the power of 6, and you get 4101 ppm.